Okay, topic 5 is about converting standard and vertex forms. So we're first going to start with some review. We're going to graph these two quadratic equations using that same process that we learned the beginning of this unit. So let's start with the one on the left, which is vertex form. Typically we would start with the line of symmetry, but the cool thing about vertex form is that we have vertex form given to us. So for this problem, let me change my pen here, I would have -5, -3, because remember vertex form, the H and the K right here are the vertex. So then I know if that's my vertex, let me go graph that my line of symmetry, which goes right through it, has to be x equals -5, because again it's a vux that goes through the vertex. So then to find my extra points, I need to plug in some numbers. Well, we typically start with 0, right? But I'm already kind of looking at this graph thinking if I do 0 somewhere along here, that's probably going to be too far out and it's going to be too big or too small, okay? In fact, I'll just tell you, if I plug in a 0, I'm going to get -53, which is obviously not on my graph, okay? So let's plug in something different. Let's plug in something that is closer to my line of symmetry. So for example, maybe a -4. Well, if I plug in a -4, let me just kind of zoom in and write it over here. If I plug in a -4 to my x, I need to do the parentheses, exponents, follow PEMDAS. So -4 plus 5 is 1. 1 squared is just 1. 1 times -2 is just -2. Then if I subtract 3, I'll have -5. So let's go put that on our graph. -4, -5. I can reflect it across my line of symmetry to get another point. But then I still need one more to make 5 points total. So again, I'm going to need to pick something that's a little bit closer to my line of symmetry. So let's go with -3. Okay, again, I'm going to plug it in. We've got -2 times -3 plus 5, all squared minus 3. Again, I got that from the original equation up here. I'm just plugging into x. So that gives me 2 squared is 4. 4 times -2 is -8. Minus 3 is -11. Well, that's not going to fit on my graph, so I'm just going to have to draw my arrows to show it's concave down. Remember that typically on a test or quiz, you need to have at least 5 points. I try really hard to make sure it does actually fit on the graph, so hopefully this will not happen on a test or quiz, because your goal is usually to have 5 points. So now let's answer the questions here in the middle. Concavity is obviously down, and it has a maximum as the vertex. The domain is all real numbers because it does go on forever. The range, though, would be y is less than or equal to, because it is pointing down, this number right here, whatever that point is, which was -3. Okay? Transformations from the parent function. Well, remember that every part of that equation is a transformation unless it's x squared. So, let me switch colors here. The -2, the negative, the 2, the 5, and the -3, those are all going to be different transformations. So starting with the negative, it's on the outside of the parentheses, so that would be a reflection over the x-axis. Which makes sense, because looking at my picture, it's concave down. The 2, it's also outside of the parentheses, so it's a vertical something, and I know that the 2 is going to make it more narrow, as you again can see in the picture. So it's a vertical stretch by a scale factor of 2. Okay, what were the other ones? The +5 and the -3. So the 5 is inside parentheses, so I know that's a horizontal something, and it's a shift because it's adding, but it's to the left 5 units, which makes sense because we see our vertex is over here, right? Then the 3 on the outside is a vertical shift down 3 units. Okay? So it's kind of a good, pretty picture of all the things we've learned so far, kind of all combined into one. It was vertex form, we did transformations, we talked about line of symmetry. So let's do it again on the right side, but this time I've been given standard form, okay? So if I want to find the line of symmetry, it's not going to be just given to me in the equation. I have to actually do x equals -b over 2a. So let's plug in our pieces here. We've got a -20, because that's b, right? A, b, and c. Times, or over 2 times a, so over 2 times -2. So that's going to be a +20 over -4, so my line of symmetry is x equals -5. Okay? Oops, I'm off by 1. Okay, so now we want to figure out the vertex. Well, I know that if the line of symmetry is -5, in order to get the y value, I just plug it in. So -2, and then I'm going to plug in my -5 that I got for x. Okay, so -5 squared is 25, times -2 is -50. -20 times -5 is +100. So now I work this out. -50 plus 100 is +50, minus 53 is -3. What do you know? My vertex is at -5, -3. Looks familiar, right? So let's find some extra points. Well, again, typically we start with 0. If I plug in a 0 here, it's really easy to see. Let me switch colors here. If I plug in a 0, well, all that's going to be 0. If I plug in a 0 here, all that's 0, and my answer would be -53. Well, again, you could tell from the problem before, that's not going to fit on the graph, and it's also no coincidence it's the same number. This is the same exact equation, just in 2 different forms. So I don't want to plug in a 0. In fact, I'm just going to use these same points over here. So we had -4. We know the answer should be -5, but let's just plug it in this equation just to make sure it works, okay? So if I plug in a -4, I've got -2 times -4 squared minus 20 times -4 minus 53. Well, this first part would be -32 because I square first and get 16 times -2. This next part would be +80. Then I'm going to subtract 53. Well, -32 plus 80 is going to give me a +48. Then if I go to subtract 53 again, that's going to give me a -5, just like I had before. Okay? And if you want, we can work out the next one, or you can just trust me that it's going to be -11 again. So we would reflect. Again, these are not going to fit on the graph, so we draw our arrows, and we're done. Also, again, concavity is down. There's a maximum, all real numbers, and the range is less than or equal to -3. Those are all going to be the same. Transformations, again, let's just say same, just to make sure that we don't waste any time doing everything all over again. The point of this first page was not only just to review the 2 different forms and how to find line of symmetry and vertex and all those things, but also to show you that we have 2 different forms and both of them have their purposes. So vertex form was the first one, and it was obviously really easy to find the line of symmetry in the vertex. Standard form was the second one, and while it doesn't have quite as many pros, like pros versus cons, it is a lot easier to plug in numbers to, okay? So like plugging in a 0, that takes all of like 2 seconds to plug into standard form, whereas it's a little bit more of a process for vertex form, okay? So they both have their merits, but we want to be able to use both interchangeably depending on what we need. So the point of